context of electrical wiring, the term sets typically refers to multiple circuits that share a common neutral conductor. This wiring configuration is a common practice in electrical systems and is often employed to reduce the overall amount of wiring required and to simplify the installation process. In a set of circuits, each individual circuit carries its own ungrounded or hot wire and is protected by its own individual circuit breaker or fuse within the electrical panel. However, all of these circuits within the set share a single, common neutral wire. This neutral wire provides the return path for the electrical current from each of the individual circuits back to the power source, which is typically the electrical panel. The use of a shared neutral conductor in a set of circuits can result in significant savings in terms of materials and labor costs, as it eliminates the need to run the separate neutral wire for each individual circuit. This can be particularly advantageous in applications where a large number of circuits are required, such as in commercial buildings or industrial facilities. However, it is important to note that the use of shared neutral conductors in electrical systems is subject to certain limitations and requirements as outlined in the National Electrical Code, or NEC. These requirements are in place to ensure the safety and proper functioning of the electrical system, and must be carefully followed to prevent potential hazards such as overloading, voltage drops, and electrical shock. One of the key considerations when using shared neutral conductors is the potential for current overloading. When multiple circuits share a common neutral wire, the current flowing through that neutral wire can be significantly higher than the current flowing through any of the individual hot wires. This is because the neutral current is the sum of the currents from all of the circuits that are sharing that neutral. If the neutral wire is not properly sized to handle the combined current load, it can become overloaded, which can lead to overheating, insulation damage, and even fire. To prevent current overloading, the NEC specifies strict requirements for the sizing of neutral conductors in multi-wire branch circuits, which are circuits that share a common neutral. These requirements typically involve calculating the maximum potential current load in the neutral conductor and then selecting a wire size that is adequate to handle that load. In some cases, it may be necessary to increase the size of the neutral conductor to ensure that it can safely carry the combined current from all of the circuits that are sharing it. Another important consideration when using shared neutral conductors is the potential for voltage drops. Voltage drop refers to the reduction in voltage that occurs as electrical current flows through a conductor. This voltage drop is caused by the resistance of the conductor, and it can become more significant as the length of the conductor increases or as the current flowing through the conductor increases. In multi-wire branch circuits, voltage drops can be a particular concern because the neutral conductor is shared by multiple circuits. If the neutral conductor is not properly sized, the voltage drop on the neutral can be excessive, which can lead to problems with the operation of electrical equipment and appliances. To minimize voltage drops in multi-wire branch circuits, the NEC specifies requirements for the maximum allowable voltage drop in branch circuits and feeders. These requirements typically involve calculating the voltage drop on the neutral conductor and then selecting a wire size that is adequate to keep the voltage drop within acceptable limits. In some cases, it may be necessary to increase the size of the neutral conductor or to use a conductor with a low resistance to minimize voltage drops. In addition to current overloading and voltage drops, another potential hazard associated with shared neutral conductors is the risk of electrical shock. If the neutral conductor in a multi-wire branch circuit is accidentally disconnected or broken, the voltage on the hot wires can become elevated, which can create a dangerous shock hazard. This is because the neutral conductor provides a return path for the electrical current, and if that path is interrupted, the current can flow through other conductive objects such as metal enclosures or the human body. To prevent electrical shock hazards in multi-wire branch circuits, the NEC requires that the neutral conductor be properly grounded. Grounding provides a low impedance path for fault currents to flow back to the power source, which helps to trip the circuit breaker or fuse and to energize the circuit in the event of a fault. Grounding also helps to stabilize the voltage on the neutral conductor, which reduces the risk of elevated voltage and electrical shock. In addition to the requirements for sizing, voltage drops, and grounding, the NEC also specifies other requirements for multi-wire branch circuits, such as requirements for the identification and labeling of conductors, the use of common trip circuit breakers, and the separation of neutral conductors from other conductors in the electrical panel. These requirements are all designed to ensure the safety and proper functioning of multi-wire branch circuits and must be carefully followed to prevent potential hazards. When working with multi-wire branch circuits, it is essential to have a thorough understanding of the NEC requirements and to follow safe work practices at all times. This includes wearing appropriate personal protective equipment, such as safety glasses and insulated gloves, and using properly insulated tools. It is also important to de-energize the circuit before working on it, and to verify that the circuit is de-energized using a voltage tester. In addition to the NEC requirements, there are also a number of other factors that should be considered when designing and installing multi-wire branch circuits. These factors include the type of load that will be served by the circuit, the length of the circuit, the ambient temperature, and the presence of any corrosive substances. By carefully considering all of these factors, it is possible to design and install multi-wire branch circuits that are safe, reliable, and efficient. It is important to note that the NEC is a complex and constantly evolving document. As such, it is essential to stay up to date on the latest changes and revisions to the code. This can be done by attending training courses, reading industry publications, and consulting with qualified electrical professionals. By staying informed about the latest NEC requirements, it is possible to ensure that electrical systems are designed and installed in accordance with the highest standards of safety and quality. Firstly, understand the basic concept. In electrical wiring, the term sets indicates multiple circuits sharing a single neutral wire. Imagine several independent electrical pathways within your home or building, each powering lights, appliances, or outlets. Instead of each circuit having its own dedicated neutral wire running back to the electrical panel, these sets combine their return paths into one common neutral. Secondly, wiring reduction. The primary reason for using sets is to reduce the amount of wiring needed. Fewer wires translate to lower material costs and less labor during installation. This can be particularly advantageous in large installations with numerous circuits. Thirdly, how it works. Each circuit in a set still has its own hot or ungrounded wire carrying the electrical current from the panel to the load. Each circuit also has its own circuit breaker or fuse at the panel for overcurrent protection. However, the neutral wires from these individual circuits are connected together at some point, usually within the panel, and then run as a single wire back to the neutral busbar in the panel. Fourthly, NEC and safety. The National Electrical Code, or NEC, provides specific guidelines and limitations for using sets or multi-wire branch circuits. These rules are in place to ensure safety and prevent hazards. One of the key concerns is overloading the neutral wire. The neutral wire carries the return current from all the circuits in the set. If the combined current exceeds the neutral wire's capacity, it can overheat, damage the insulation, and potentially cause a fire. Fifthly, current balance. The NEC allows sets when the load is balanced across the hot wires. Ideally, the current flowing through each hot wire should be roughly equal. This minimizes the current on the neutral wire. For example, consider a set with two 120-volt circuits. If one circuit draws 10 amps and the other also draws 10 amps, the neutral wire will carry little to no current because the currents are effectively cancelling each other out. Sixthly, unbalanced loads. If the load is significantly unbalanced, the neutral wire will carry substantial current. The NEC specifies that the neutral conductor must be sized to handle the maximum possible unbalanced load. This often means using a larger gauge wire for the neutral than for the hot wires. Seventhly, common trip breakers. To prevent hazards when working on sets, the NEC typically requires the use of common trip circuit breakers. These breakers simultaneously disconnect all the hot wires in the set if one circuit experiences a fault. This prevents someone from inadvertently working on a live circuit while thinking the power is off. Eighthly, neutral disconnects. The NEC also prohibits the use of single-pole switches or disconnects on the neutral wire of a multi-wire branch circuit. This is because disconnecting the neutral can create a dangerous voltage imbalance and potentially damage equipment. Ninthly, identification. Proper identification of the wires in a set is crucial. The NEC requires that all conductors be clearly labeled to indicate their function. This helps prevent confusion and ensures that electricians can safely work on the circuits. Tenthly, qualified electrician. Due to the complexities and safety considerations involved, working with sets or multi-wire branch circuits should always be done by a qualified electrician. They have the knowledge and experience to properly design, install, and maintain these systems according to the NEC and local codes. Consider this an example. Imagine a small office space with 3 separate 120 volts lighting circuits. Instead of running 3 individual neutral wires back to the electrical panel, an electrician might choose to use a set. They would run 3 hot wires, 1 for each circuit, and a single, larger neutral wire that is sized to handle the combined load of all 3 circuits. Each circuit would have its own 15 amp circuit breaker at the panel. To comply with the NEC, the electrician would likely use a common trip breaker to ensure that all 3 circuits are disconnected simultaneously in the event of a fault. They would also carefully label all the wires to clearly identify their function. The shared neutral wire would need to be sized according to NEC tables, considering the potential for unbalanced loads. The advantage of this approach is that it reduces the amount of wiring required, saving both time and money. However, it's crucial to follow all the NEC guidelines to ensure the safety and proper functioning of the electrical system. Failing to do so can lead to overloading, voltage drops, and potential fire hazards. Understanding these nuances is important for electrical safety and efficiency. The concept of sets in electrical wiring primarily refers to multi-wire branch circuits, or MWBCs. These are configurations where 2 or more ungrounded conductors originating from different phases or lines of a multi-phase system share a common neutral conductor. The NEC addresses MWBCs in various sections, outlining specific requirements to ensure safety and proper operation. The main advantage of using MWBCs is the reduction in the number of conductors required, leading to cost savings and easier installation. However, this advantage comes with its own set of challenges and safety considerations. A critical aspect of MWBCs is the balanced load requirement. Ideally, the loads connected to each ungrounded conductor should be balanced to minimize the current flowing through the neutral conductor. In a perfectly balanced system, the neutral current would be 0. However, in reality, achieving perfect balance is difficult, and the neutral conductor must be sized to accommodate the maximum possible unbalanced load. The NEC specifies the method for calculating the neutral conductor size based on the expected unbalanced load. The NEC mandates the use of a multi-pole circuit breaker or a means to simultaneously disconnect all ungrounded conductors of the MWBC at the origin. This is essential for safety during maintenance and troubleshooting. If one ungrounded conductor is disconnected while the others remain energized, it can create a dangerous situation where the neutral conductor carries excessive current, potentially leading to overheating and fire. Another important consideration is the identification of MWBC conductors. The NEC requires that all conductors of an MWBC be clearly identified to prevent confusion and ensure proper connections. This typically involves color coding or labeling the conductors to indicate their phase or line. Grounding is also crucial in MWBCs. The neutral conductor must be properly grounded to provide a low impedance path for fault currents, minimizing the risk of electric shock. The grounding system must comply with the NEC requirements for grounding electrode systems and equipment grounding conductors. When working with MWBCs, it is essential to follow safe work practices. This includes energizing the circuit before working on it, using appropriate personal protective equipment such as insulated gloves and safety glasses, and verifying that the circuit is energized using a voltage tester. It is also important to have a thorough understanding of the NEC requirements for MWBCs and to consult with a qualified electrician if you have any questions or concerns. The NEC also addresses specific applications of MWBCs, such as in dwelling units and commercial buildings. These applications may have additional requirements or restrictions depending on the specific circumstances. For example, in dwelling units, the NEC may limit the number of circuits that can be served by an MWBC. In commercial buildings, the NEC may require additional overcurrent protection for MWBCs serving sensitive electronic equipment. Furthermore, voltage drop calculations are essential in MWBC design. Excessive voltage drop can lead to poor performance of connected equipment and appliances. The NEC provides guidelines for calculating voltage drop and recommends limiting the voltage drop to a certain percentage of the supply voltage. This may require increasing the size of the conductors to reduce resistance and minimize voltage drop. Surge protection is another important consideration for MWBCs. Surges can damage sensitive electronic equipment connected to the circuits. Surge protective devices, or SPD, can be installed to protect against surges. The NEC provides requirements for the installation and location of SPD. Additionally, arc fault circuit interrupters, or FSIs, are often required for MWBCs serving certain areas, such as bedrooms and dwelling units. FSIs are designed to detect arc faults, which are a common cause of electrical fires. The NEC specifies the locations where FSIs are required. In summary, MWBCs are a useful wiring method for reducing the number of conductors required, but they must be designed and installed in accordance with the NEC requirements to ensure safety and proper operation. Careful attention must be paid to load balancing, conductor sizing, overcurrent protection, grounding, and identification. Working with MWBCs requires a thorough understanding of electrical principles and the NEC, and it is recommended to consult with a qualified electrician for any complex or critical applications. The NEC is not static. It is updated regularly to reflect new technologies and safety concerns. It is important to stay current with the latest edition of the NEC to ensure that electrical installations comply with the most up-to-date requirements. Training and education are essential for electricians and other electrical professionals to stay informed about the NEC and best practices for electrical safety. There are numerous resources available, including training courses, seminars, and publications. Multi-wire branch circuits can be a cost-effective and efficient wiring method when implemented correctly and in compliance with the NEC. However, they require careful planning, design, and installation to ensure safety and reliability.